Now, where composition of functions get complicated is when we take away the numbers. And this is what we were looking at yesterday when I said we had like the function 1000 machine and that wasn't yesterday, but a couple of days ago, that we were making the fractions, right? The fraction 1000 machine. And he had two machines that made the fractions. Then he bought the new one, and it was one machine. That's what's happening here. Here I've got one machine, which is 2x squared plus 1. So there's my first machine, f of x. And then I've got a second machine, which is g of x, which is 2x plus 7. So what would happen if I would throw a 1 into f of x? What would come out? Makes sense that out would come a 3. And then if the 3 went into g of x, what would come out? 13. Does that make sense? If you threw in a 2 into f of x, out would come a 9. And then the 9 would go into g of x, and out would come 25. So the question is, what function would be in here so that if you threw in a 1, out would come a 13. If you threw in a 2, out would come a 25. What would that be? That's right. So what's going to happen? So if I plug in an x into here, what's going to come out of the f of x machine? Out's going to come 2x squared plus 1. Does that make sense? Like, you can throw anything into the f of x. If we threw Jason into the f of x machine, what would come out? 2 Jason squareds plus 1. Whatever that would be. Okay? You can throw anything in. Whatever you throw in, this function f of x takes, this is the idea, it takes whatever you throw in, it squares it, times it by 2, and adds 1. So if you threw a happy face in, the happy face would get squared, it would get multiplied by 2, and then you would add 1. What does g of x do to whatever you throw in? Whenever you throw something into g of x, it gets multiplied by 2, and then you add 7. So what would happen if I threw in x squared, 2x squared plus 1 into the g of x? It would get doubled. So you would go, what would come out would be 2 times 2x squared plus 1. And then you add 7 to it. If I simplified that, can you see that you have 4x squared plus 9? That is what is right in here, 4x squared plus 9. Throw in 2. 2 squared is 4. 4 times 4 is 16 plus 9, 25. Throw in 1. 1 squared is 1 times 4 is 4 plus 9, 13. This is the idea. What we just did here was b. What is g of f of x? The way that we would show b, and we'll do b first just because we've got all this work here. The way that we would show our work for this if we wanted to find g of f of x, the first thing we need to do is we need to put x into f. If we put x into f, we get 2x squared plus 1. Because what does f of x do? It says whatever you put in, which we've highlighted up here in yellow, whatever we put in gets squared, you times it by 2, and you add 1. The g function says whatever you put in gets multiplied by 2, and then you add 7. So if we put 2x squared plus 1 into g, the g function says whatever you put in gets multiplied by 2, and then you add 7. I'm going to highlight this in green and highlight it here in green. What you need to be able to see as far as the abstractness of this is that's the same as I highlighted up in green right at the beginning. Whatever I throw in, you multiply it by 2 and add 7. So if I throw in 2x squared plus 1, it gets multiplied by 2 and you add 7. That's what that function does. Now if we simplify this, we get 4x squared plus 2 plus 7 makes plus 9. So I want you to try A and C, f of g of x and g of x. So in A, we are trying to find f of g of x. G of x is equal to 2x plus 7. And the f function says whatever you put in, if we go look back at our f function here, we highlight it in yellow. Whatever gets put in gets squared, gets multiplied by 2, and then you add 1. So whatever we put in gets squared, multiplied by 2, and then you add 1. If we multiply this out, order of operations say square first. So 2x plus 7 times 2x plus 7, you'd have to FOIL and simplify. Which I believe, did you get 4x squared plus 28x plus 49? Now you can multiply that all by 2, which will give you 8x squared plus 56x plus 98 plus 1 will be plus 99. Okay? This would not be an easy thing if I had that as the function to start with and I said, plug in a number, 1. And then I tell you, oh, this is what comes out. I think it would take a long time to try to figure out that that was the function. But it's possible. And then for part C, which was g of x, first of all, the function g says whatever you put in, you multiply it by 2 and add 7. So if I put in 2x plus 7 into the function g, whatever I put in, so I put this in, gets multiplied by 2, and then you add 7. So this will be 4x plus 14 plus 7 will be plus 21. (10 and 11) for practice. Oh, and we haven't done domain and range. So when you're figuring out domain and range for each of these, we'll go right back to the beginning. It makes sense to simplify your function. You're not going to be able to tell what the domain and range are just by looking at f of x and g of x. You have to put them together and simplify them. Once you've simplified them, so for this first one, what kind of graph is 4x squared plus 9? It's a parabola. What's the domain of a parabola? X is an element of the reals. Everything is possible. There are no non-permissible values here. Think of your transformations unit. What is the range of this going to be? Y has to be bigger than or equal to 9. because it's a parabola that opens up. It's been stretched vertically, but then it's been translated 9 units up. For our second one, it's another parabola. So what's the domain going to be? Everything is possible. As far as the range, you would have to know what the vertex is, right? And we could complete the square for this to find the vertex, but this one is more complicated to complete the square. It would take us some time. It's not complicated to complete the square, but the numbers aren't that nice. What you could do is type this into your graphing calculator. It's a parabola that opens up, and if you found the vertex, then whatever that vertex would be the smallest y value. Does everybody know how to find the vertex with their graphing calculator? No. Find the minimum, so you type it into your calculator, find the minimum. We won't do that right now just because it takes some time. We'll look at the last one. What kind of graph is the last one? It is a line. So the domain is everything, and the range is everything. Again, the questions you can do are number 10 and 11.